Neural networks are like intricate puzzles, and backpropagation is the key that unlocks their potential. So, today we will unveil the mysteries of backpropagation, that is, the algorithm that drives the training of neural networks and will help you grasp its significance in unlocking the power of AI. So, let's get started with what is backpropagation algorithm. Now, the backpropagation algorithm is a fundamental technique used in training artificial neural networks, particularly in deep learning. It is a method for adjusting the weights of neural network based on the error between its predicted output and the actual output. And the goal is to find the optimal set of weights that minimize the error. So imagine a political pollster want to predict the outcome of a presidential election using a neural network. Now, the input to the neural network could be a set of features such as voters' demographics, polling data, and candidate policies. And the output would be a prediction of the percentage of votes each candidate is likely to receive. So, during the training phase, the pollster uses the backpropagation algorithm to adjust the weights of the neural network. And this can be done by propagating the input data, that is, say, voter demographics, through the neural network to generate a predicted output, that is, a percentage of votes for each candidate. Then comparing the predicted output with the actual election results, which shall become a ground truth. Then calculating the error between the predicted and actual results. And finally, propagating this error back through the network to adjust the weights in a way that minimize the error. Now, this backpropagation algorithm is a gradient based method, which means it adjusts the weights in the direction that decreases the error. And these adjustments are proportional to the error and the bold math derivative, that is the slope of the error with respect to each weight. And this process of propagating the input data through the network, calculating the error and adjusting the weights is repeated multiple times until the neural network achieves satisfactory performance in predicting the election results. In simple terms, we can say the backpropagation algorithm helps the neural network learn by adjusting the weights based on how much the predicted output deviates from the actual outcome. And by repeating this process, the neural network becomes better at making accurate predictions for future elections. So let's understand it better using a Python code. Now, this code defines a simple neural network with a single layer in Python using the NumPy library. Now, here the neural network has two input neurons and one output neuron. And the goal is to train the network to perform a simple but non-linear problem such as XOR operation. Now, here the code consists of two parts. First is the neural network definition and the training loop. Now, first we will have the neural network definition, where the simple neural network class defines the neural network for two methods. Init method will initialize the neural network by setting the weights and biases randomly. The number of inputs and neurons are passed as arguments. Then this forward method. Now, this method performs the forward pass, computing the output of the neural network given the input. It calculates the dot product of the input and the weights, then add the biases to obtain the final output. Then we have backward pass. Now, this method performs the backward pass, that is the back propagation, updating the weights and bias of the neural network given the input target and learning rate. And it calculates the deltas for the weights and biases, update them using the learning rate, and stores the updated values. Then we have a training loop. Now, this training loop trains the neural network by iterating over a set of input target pairs 10,000 times, and for each iteration the backward method is called and the weights and the biases are updated. Now, this learning rate controls how much the weights and biases are updated at each iteration, and after every 1,000 iteration the current weights and biases are printed. Now, this code demonstrates the basic concept of neural network and backpropagation, but it's a simple example. For more complex problems, you'll need to adjust the number of inputs, neurons, and training data accordingly. Thank you.